There are over 8 billion humans alive today. From the tallest cities to the most remote deserts, it feels like we've filled every corner of the planet. We build, we invent, we send machines into space. It almost seems as if our success was guaranteed. But less than 1 million years ago, the human story nearly ended. Not figuratively, literally. Around 900,000 years ago, the entire population of our ancestors collapsed. Not millions, not hundreds of thousands. Just about 1,280 breeding individuals remained on Earth. That is the razor's edge we balanced on. The whole future of humanity. Every language, every song, every child who would ever be born, hung by the thinnest possible thread. And the strangest part? We didn't even know about it until 2023. For decades, scientists had suspected something odd. Humans today carry far less genetic diversity than other animals. Even chimpanzees, scattered in small groups, show more variation than all 8 billion of us combined. That's not normal. It's the fingerprint of a catastrophe. But no one realized just how severe it was until new computational tools made it possible to trace our DNA back almost 1 million years. What they revealed was astonishing. Around 930,000 years ago, nearly 99% of our ancestors were wiped out. For more than 117,000 years, humanity clung to existence at critically low numbers. Normally, species that fall that far don't recover. They vanish forever. But somehow, our ancestors endured. Before I go deeper, let me just say, if you are using this video to relax or to fall asleep, that's exactly why I make it. Leave a quick comment, maybe just your city or the time you're watching. It's always incredible to see the mix. Tokyo at midnight, Berlin at breakfast, Los Angeles at sunset. We're all here, listening to the same ancient story. And this story really is ours. Every single person alive today is descended from those survivors. Whether you live in Nairobi, New York, or New Delhi, your DNA carries the echo of that near-death experience. Imagine 8 billion humans today, disappearing one after the other until there are just 1,280 left. That is where our story begins. The discovery came from a scientist named Wang Zhu, working with colleagues at the Chinese Academy of Sciences. Around 5 years ago, they were analyzing DNA from thousands of people around the world, trying to reconstruct the deep history of human populations. With a new method, the FitCoal model, they could look much further back than ever before. And what they saw shocked them. In the genetic record, diversity suddenly collapsed. It was like watching a movie where nearly all the characters vanish at once. Only a handful remain on screen. At first, Wang thought it was an error. The numbers were unbelievable. A bottleneck that reduced humanity to fewer than 1,300 people? That is the threshold biologists call the extinction vortex, a place from which most species never return. But when the team tested it again and again with different data and different models, the answer never changed. Something catastrophic had happened. The survivors weren't just small in number, they stayed small. For more than 100,000 years, humanity lived in this fragile state. Picture generations upon generations, raising children and hunting food, all under the constant risk that one drought, one epidemic, one bad year could end everything. And yet, against the odds, they survived. That's the legacy written in your DNA and mine, the reason we exist at all. This realization reshapes how we think about ourselves. Geneticists have long puzzled over why humans seem so similar to one another despite our vast numbers. Now we know. During this bottleneck, we lost as much as 65% of our genetic diversity. That loss is why we're unusually prone to some diseases, why certain genetic disorders are more common than they should be. But it also means we are all profoundly related. Chimpanzees in two different valleys are more different from each other than you are from someone on the opposite side of the earth. And that brings us to the deeper mystery. What caused this? What kind of world could have driven humanity to the brink of extinction and kept us there for 117,000 years? But for now, let this sink in. Every city, every culture, every person you know, all of it, descends from about 1,280 survivors. The fact that you're alive today means your ancestors were among them.
Chapter 2: The Climate Catastrophe. Around 900,000 years ago, the Earth itself turned hostile. What had once been a relatively predictable planet shifted into a new and brutal rhythm, one that transformed entire continents and forced our ancestors into a struggle for survival unlike anything before. The scientists who traced the human bottleneck back through DNA quickly realized that the timing was not a coincidence. The collapse of human populations lined up almost perfectly with one of the most dramatic climate transitions in Earth's recent history. Before this point, the world was governed by steady, almost clock-like ice age cycles. Every 41,000 years or so, the tilt of Earth's axis changed just enough to bring colder conditions. Glaciers grew, seas receded, then warmth returned. These swings were challenging for early humans, but they were predictable. You could almost set a calendar by them. Life found ways to adapt. Then something shifted. Astronomical cycles, tectonic forces, and feedback loops in the oceans all combined into a new pattern. Instead of shorter ice ages, the planet fell into 100,000-year cycles. The glaciers grew larger than ever before, swallowing continents in vast sheets of ice. Sea levels fell by hundreds of feet, exposing new land bridges while cutting off coastlines. Ocean currents weakened, storm systems changed, rainfall patterns collapsed. Nowhere felt this more severely than Africa. The continent that had once been a patchwork of woodlands, rivers, and grasslands became increasingly dry. The monsoon systems that had watered the interior grew erratic, sometimes failing for centuries. Forests shrank, Grasslands turned to scrub, then to desert. For the humans living there, species like Homo erectus or their close descendants, this meant catastrophe. The animals they hunted disappeared. Plants that had fed countless generations vanished. Lakes and rivers shrank to dust.
Imagine being part of a small band of early humans at this time. You would have known the land by heart. You would have followed herds across valleys, returned to the same watering holes season after season. Then, within the span of a few generations, everything you knew stopped working. The watering holes dried out. The herds grew thin, then were gone. Even the plants you could once rely on failed. One by one, your options disappeared. The land itself seemed to turn against you. It was not a single year of famine. It was not a short drought. It was the new normal, and it lasted for thousands upon thousands of years. Scientists call this process aridification, when once lush ecosystems collapse into dryness. Fossil records from this time show mass extinction sweeping through Africa. Large mammals that had thrived for millions of years suddenly vanished. Antelope species, elephant populations, entire food chains collapsed. Predators starved, scavengers starved, and humans, standing somewhere between predator and scavenger, found themselves in desperate competition for whatever scraps remained. This was the perfect storm that created the bottleneck. For humanity, survival meant improvisation. Groups who relied on large game hunting likely disappeared first. The environment could no longer support herds big enough to feed them. Those who survived had to become dietary opportunists, willing to eat almost anything: insects, roots, tubers, small animals, eggs. They all became staples. Fire, which may have been used sporadically before, now became essential. With fire, you could make otherwise inedible plants safe to eat, or stretch a small amount of meat much further. Without it, survival in such a barren landscape would have been nearly impossible. The struggle was not just about food. Water dictated everything. In a land where rivers ran dry for most of the year, bands of humans had to learn to track the faintest signs of underground springs or seasonal streams. A group that failed to find water quickly enough would not last long. And so knowledge, where to dig, where to wait, how to follow the animals who still knew the secret places, became as valuable as the water itself. In such conditions, knowledge was survival. The pressure on early humans was immense. Populations shrank not in decades, but in generations, slowly but inexorably, until only that tiny remnant remained. 1,000 here, a few hundred there, scattered across Africa, holding on in isolated pockets where water and food were still barely enough. They were not a single village or tribe living together. They were fragments, separated by hundreds of miles of hostile terrain, clinging to life in scattered refuges.
The fossil record from this period tells us very little. In fact, there is a puzzling gap. Almost no human fossils appear between about 950,000 and 650,000 years ago. Anthropologists puzzled over this for decades, calling it the fossil void. Now the explanation is clear. There were so few humans alive that the odds of their bones being preserved and later discovered were vanishingly small. Entire generations could live and die without leaving a single trace for us to find. And yet, Against all odds, they endured. 1,000 here, 1,000 there, sharing knowledge within their groups, passing survival skills to children who would grow up in a world harsher than their parents had ever known. Every new drought, every failed hunt was another test. Those who could not adapt vanished. Those who could passed on their resilience. When scientists today look back at this period, they see more than just a population crash. They see a crucible. Humanity was being tested by Earth itself. For 117,000 years, our ancestors lived on the edge of extinction, their fate balanced on each new season of rain or drought. In this pressure cooker, traits like cooperation, innovation, and adaptability were not luxuries. They were the difference between life and death. What makes this story even more extraordinary is that while almost all other human lineages of the time disappeared, this tiny, fragile population somehow found a way to persist. They endured ice ages that covered continents, droughts that erased rivers, and famines that lasted lifetimes. And they carried forward the spark of humanity, the spark that would one day ignite into everything we see today. The climate had changed. The world was brutal. But still, somewhere in Africa, a few thousand survivors refused to give up.
Chapter 3. Life on the Edge. To imagine what it meant to be one of those last 1,280 humans, you have to strip away everything familiar. No cities, no farms, no villages, not even the certainty of food from one day to the next. Life was reduced to its most basic terms: water, food, fire, and the fragile thread of social connection. These groups were small, perhaps 20 to 30 individuals at most, extended families bound together by necessity. Every adult, every child, every elder mattered. To lose even a single person was dangerous. Each pair of hands could carry water, gather food, keep watch for predators. Each set of eyes could notice signs of rain or hidden streams. Survival was not an individual achievement. It was a collective one. Food was a daily struggle. With most large game gone, hunting shifted from grand pursuits to opportunistic snatches of chance. A young antelope cut off from its herd, a weakened zebra, or the rare carcass of a larger animal could provide a short-lived feast. But more often, survival depended on smaller, humbler sources of nutrition. Insects were reliable. Termites packed with protein. Crickets and beetle larvae roasted quickly over embers. Roots and tubers dug from the dry earth filled bellies when nothing else was available. Eggs, whether from birds nesting in hidden cliffs or reptiles along riverbanks, were prized treasures. This forced diet turned our ancestors into what anthropologists call generalists. They ate anything they could find, anything that would sustain life for one more day. Over time, this adaptability became a defining human trait. Unlike species specialized for one type of food, humans learned to survive by never depending on just one. Fire became more than a tool. It became a lifeline. Cooking softened tough roots, neutralized poisons, and released calories locked inside otherwise useless plants. Fire transformed meager scraps into meals that could keep a child alive through lean months. It also pushed back predators and extended waking hours. After sunset, while other animals retreated into the dark, humans gathered around flames, repairing tools, telling stories, passing on knowledge. That firelight was the original classroom, the place where children learned not only how to survive, but also who they were. Water, however, was the constant obsession. In this dry, shifting climate, the search for water shaped every movement. Groups became experts at reading the land. A cluster of green trees might hint at an underground spring. The behavior of animals revealed hidden sources. Perhaps humans even dug crude wells with sticks and stones, scraping down into the earth for life-giving groundwater. Knowing where to find water was more valuable than any spear or stone tool. Without it, no band could last. Social bonds grew out of this relentless struggle. Conflict within the group was a luxury no one could afford. Cooperation was not just preferred, it was mandatory. When one person found food, it was shared. When someone learned how to prepare a poisonous plant safely, the knowledge spread to all. To hoard was to endanger everyone. Trust, patience, and empathy became survival skills as vital as hunting or gathering. This is where the seeds of what we recognize as human culture began to take root. Knowledge could not be allowed to die with an individual. Oral traditions, rudimentary but powerful, emerged to carry skills from one generation to the next. A child who knew where the seasonal stream flowed, who could recognize which root was edible, who understood how to coax sparks into flame, was a child who might live long enough to have children of their own. The more quickly young people could learn, the greater the odds that the group would survive. Over thousands of years, this relentless pressure selected for bigger, sharper brains and for the ability to teach and learn with unusual efficiency. Inbreeding was inevitable. With such tiny numbers, genetic problems must have been common. Birth defects, reduced fertility, vulnerability to disease. Many groups likely disappeared entirely, but the few that persisted passed along not just genes, but hard-earned resilience. Their very survival meant they carried something, whether in body or behavior, that worked. And so generation after generation, the fragile chain continued.
Imagine waking each morning in that world. There is no guarantee of food. The nearest water might be a day's walk away. Predators circle at the edges of camp. The heat of the day threatens dehydration. The cold of the night demands fire. Your group moves constantly, chasing the faint promise of survival. Sometimes there is plenty, an animal kill, a stretch of berries, a pool that lasts longer than expected. Other times, children cry with hunger, and adults grow thin and desperate. Yet even in this harsh life, there was connection. At night, around the fire, bonds deepened. Stories of past seasons, of remembered rains,
of ancestors who endured even harsher times would have been told again and again. Those stories were not entertainment. They were survival guides disguised as memory, ways of encoding information so that the next generation could remember when the details mattered most. In those flickering shadows, the roots of language were stretching, pushed forward by the pressure to survive. Over tens of thousands of years, these scattered groups were not static. They rose and fell, sometimes disappearing entirely. But as long as at least one group endured, humanity endured. Biologists call this a metapopulation, a network of small, vulnerable communities, each one fragile, but together able to persist. One band might vanish after a drought. Another might recover after finding a new refuge. The pattern continued like a long, slow heartbeat, carrying the species through the darkest ages of its existence. Life for those 1,280 humans was not heroic in the way we often imagine survival. It was not marked by grand discoveries or triumphs. It was ordinary persistence, digging, gathering, sharing, protecting, and hoping the next season would not be worse. And yet, in that ordinariness, something extraordinary was taking shape. The behaviors that define us, our cooperation, our capacity for teaching, our adaptability, were being forged day by day, fire by fire, in the most unforgiving classroom nature ever created. Everything we are today, the ability to live in vast cities, to explore the stars, to share stories across oceans, rests on the fragile endurance of those scattered families who refused to give up. Their world was small, but the consequences of their survival were infinite. And as the millennia passed, pressure turned into transformation. The bottleneck was not only endured, it began to shape what humanity would become.
Chapter 4: Evolution in the Pressure Cooker. When a species is reduced to just over 1,000 individuals, survival alone is remarkable. But survival was not the only thing that happened during those long, dry millennia. The bottleneck did more than threaten to erase humanity. It reshaped us. It turned evolution from a slow drift into a roaring current, forcing changes that would define who we are. Normally, genetic variation spreads through large populations slowly. A useful trait, better eyesight, stronger bones, sharper memory, might take tens of thousands of years to become widespread. But in the population as small as 1,280, change can sweep across every member in only a few generations. A single mutation, if it helps even slightly, can rapidly become universal. The bottleneck turned early humans into an evolutionary pressure cooker, where only the traits that truly improved survival had a chance to endure. One of the most remarkable outcomes was in the brain. Fossil evidence from just after the bottleneck shows a gradual but measurable increase in cranial capacity. Our ancestors' brains were getting bigger, not dramatically, not all at once, but enough to notice. A larger brain is costly. It requires more energy, more nutrients.
In times of scarcity, that should have been a disadvantage, and yet larger brains persisted. Why? Because they conferred something more valuable than calories: adaptability. In a world where water sources vanished and food chains collapsed, the individuals who could think ahead, improvise, and share knowledge had the edge. Problem solving became as essential as sharp teeth or strong limbs. Over time, intelligence itself became a survival trait, sculpted by the relentless demands of a hostile climate. But intelligence on its own was not enough. Survival required groups, and groups required something more subtle: the ability to understand one another. Imagine a band of 30 people all depending on each other. One careless mistake could cost lives. To endure, our ancestors had to read intentions, predict behavior, and manage conflict without breaking apart. This is where psychologists believe the roots of theory of mind were refined: the awareness that other people have thoughts and feelings separate from your own.
It may have started in simple forms, recognizing when someone else was angry or afraid, noticing when a hunter was hiding excitement at spotting game, sensing when a child was about to wander into danger. But over generations, this ability grew sharper. Those who understood others better could cooperate more effectively, could build trust, could keep the fragile group from tearing itself apart. The bottleneck selected not only for intelligence, but for empathy. Alongside this came the refinement of language. Words, as we know them today, leave no fossils. We cannot dig into the earth and find sentences, but indirect evidence suggests that the bottleneck was the time when communication grew vastly more complex. Passing knowledge from one generation to the next required precision, knowing which roots to eat and which would kill, remembering which valleys still held water, teaching fire-making techniques. All of this demanded more than vague gestures. Sounds and symbols had to become richer, more structured. Even simple advances in communication would have meant the difference between life and death. A band that could describe in detail where food could be found had a higher chance of survival than one that relied on trial and error. Over thousands of years, selection favored individuals who could speak more clearly, understand more quickly, and teach more effectively. Language was being forged in the furnace of necessity. Tools also evolved under this pressure. For millions of years, humans had shaped stone into simple hand axes and choppers. Useful, yes, but limited. During the bottleneck, something shifted. Stone tools became more standardized, as if groups had settled on methods and taught them systematically. Archaeologists see signs of cultural convergence, the same tool designs appearing in different places, suggesting knowledge was spreading beyond single groups. Perhaps bands met occasionally, not only exchanging marriage partners, but also techniques. Each encounter a spark that kept the flame of innovation alive.
And fire itself, once a rare and fragile discovery, became central. Groups that mastered fire could expand diets, ward off predators, and extend social life into the night. Fire allowed them to inhabit environments that would otherwise have been unlivable. Archaeological evidence shows a sharp rise in the controlled use of fire around 800,000 years ago, just as populations were beginning to recover. It is tempting to see a connection. Fire may have been the tool that pulled humanity out of the bottleneck. But perhaps the most profound adaptation was not physical, nor even technological. It was social. In such tiny populations, no one could afford isolation. Bands had to cooperate, not just within themselves, but sometimes across distances. A group that suffered heavy losses might be replenished by marriages or alliances with others. Genetic evidence suggests that early humans formed what biologists call a metapopulation, a loose network of small groups connected by occasional exchanges. This structure prevented the extinction of the entire species when individual groups failed. Cooperation was everything. To share food, to care for the sick, to teach children, to remember water sources, to resolve disputes without violence. All of these behaviors became deeply ingrained. Over generations, natural selection rewarded not only the strongest hunters, but the best collaborators. Human success began not with dominance, but with cooperation. The bottleneck did not just test humanity, it shaped us. The traits we most often see as uniquely human, intelligence, empathy, communication, tool use, teaching, were not luxuries added later. They were survival strategies born out of desperation. Without them, the last 1,000 humans on Earth would have faded into the dust of forgotten extinctions. Instead, those traits carried them through 117,000 years of hardship. And when the climate finally began to ease, when rain returned and ecosystems slowly recovered, humanity was no longer the same. We had been transformed. The bottleneck was not only a trial, it was a forge, and from it emerged a species ready to shape the world in ways no other had before.
Chapter 5: The Silence of Bones. For over 200 years, scientists have searched the ground for traces of our ancient past. Fossils, fragments of bone, chipped stones, all are clues in the great puzzle of human origins. Yet when we look at the period between about 950,000 and 650,000 years ago, we find almost nothing. This absence was long considered a mystery, a baffling silence in the record. It was as if humans had simply vanished from the earth. Archaeologists gave it a name, the fossil gap. Entire shelves in museums remained empty because the earth itself seemed to have forgotten that we existed. For decades, theories abounded. Perhaps the right sites had not been discovered. Perhaps bones had been destroyed by erosion or buried beyond reach. Perhaps our ancestors had lived in regions where fossilization was rare. But when geneticists revealed the truth in 2023, everything fell into place. There were not many fossils from this period because there were not many humans alive to leave them. With only about 1,280 breeding individuals scattered across Africa, the odds of one of them dying in just the right conditions to become a fossil, and for that fossil to survive 1,000,000 years, and then be found by modern science, were incredibly small. It was like trying to find a single drop of water in the desert. The silence of bones is not an accident. It is a reflection of reality. For over 100,000 years, humanity was almost gone. The gap is striking not only in Africa, but across Europe and Asia as well. A few scattered remains have been discovered, fragments of jawbones, pieces of skulls, stone tools that may date to this period, but they are rare and often uncertain. This absence now makes sense. The bottleneck was not local, it was global. Even if some populations survived outside Africa, they too were reduced to such low numbers that their traces are almost invisible. Yet the bones may be silent, but the DNA is not. In our genomes, the story of that near extinction is written clearly. Modern humans carry unusually low genetic diversity compared to other primates. Chimpanzees in two different valleys can be more genetically different from each other than two humans on opposite sides of the world. This strangeness puzzled scientists for years. Now we know why.
During the bottleneck, humanity lost an estimated 65% of its total genetic diversity. Think about that. More than half of all possible variation vanished forever. It was like pruning a tree until only a few branches remained. Everything that came afterward grew from that reduced stock. This loss has consequences that echo through us even today. One of them is our vulnerability to disease. Genetic diversity is like a library of defenses. The more variants a species carries, the more likely some individuals will resist new pathogens. When diversity is low, a single disease can sweep through a population unchecked. That is why human beings, despite our intelligence and technology, are often more fragile in the face of viruses than other mammals. We carry the scars of that ancient pruning. Certain disorders may also trace back to this event. Conditions that in larger, more varied populations might have been diluted or eliminated could instead have been locked into the human gene pool. When only a few hundred families carried the future of the species, whatever genes they bore, good or bad, became the foundation for us all. Some diseases that trouble us today may be side effects of traits that proved useful back then, or simply the unlucky baggage of survival. But there is another side to this story. The same narrowing that left us vulnerable also unified us. Despite the surface differences we see, skin colors, facial shapes, languages, cultures, the genetic differences between human populations are astonishingly small, far smaller than many expect. That unity is the direct result of the bottleneck. We are all descended from the same small group. In a very real sense, every human being alive today is family. This is not metaphor, it is measurable. If you were to compare the DNA of a person in Iceland with someone in Ethiopia, the variation you would find is less than what exists between two chimpanzees living a few hundred kilometers apart. The fossil gap shows us how few of us were left. Our genomes show us what that meant for our future.
And there is one more piece of evidence. One of the strangest genetic fingerprints in all of biology. Somewhere during this period, two chromosomes fused into one. Chimpanzees and gorillas carry 48 chromosomes. Humans carry 46. The reason is that in one of those last small populations, a rare fusion event occurred. Two ancestral chromosomes joined together into what we now call chromosome 2. In a large population, such a mutation might have vanished, lost among millions of other genetic variants. But in a group as small as 1280, it had a chance to spread rapidly. Within a few generations, it may have become universal. And today, every single human alive carries it.
Scientists can point to the exact spot where the chromosomes fused, the molecular scar of that ancient accident. Some researchers even suggest this fusion may have influenced brain development. Genes near the fusion site are linked to neural growth. It is possible, though not proven, that this mutation contributed to the expansion of human intelligence. If so, then our very capacity for thought, for language, for imagination may be the unintended gift of a genetic quirk that survived only because our ancestors were so few. The fossil gap is haunting. It reminds us how close we came to vanishing, how little separated us from the countless species that disappeared without a trace. But it is also humbling. Every weakness we carry, every susceptibility to disease, every genetic oddity in our lineage is part of the price of survival. We are not a species untouched by struggle. We are a species shaped by it. So when we look at the empty layers of Earth, the missing bones, the silence of fossils, we should not see absence alone. We should see endurance. For those 100,000 years, scattered bands of humans carried forward the spark of life through famine and drought, through loss and hardship. They left few bones for us to find, but they left their legacy in our chromosomes, in our brains, in every heartbeat of the billions alive today. The silence of bones is not a gap in the story. It is the story itself, a story of fragility, of loss, and of survival against the longest odds.
Chapter 6: The New Beginning. For more than 100,000 years, humanity had been reduced to its thinnest thread. Bands of survivors scattered across Africa, clinging to life in hidden refuges, passed the torch from one generation to the next. And then, almost suddenly in evolutionary terms, the story changed. Around 813,000 years ago, the climate began to shift once more. The long, arid grip of the early Middle Pleistocene transition loosened. Rains returned to regions that had been barren for millennia. Grasslands expanded. Lakes filled again. Animals that had vanished from vast areas reappeared in herds, timid at first, then plentiful. For our ancestors, this was like waking from a nightmare into a world that once again offered possibilities. The effect on population was explosive. Those tiny, fragile groups, only a few thousand souls across an entire continent, multiplied. Within just a few thousand years, their numbers expanded far beyond what had seemed possible. For a species on the brink of extinction, this rebound was nothing short of miraculous. But the survivors who began to grow and spread were not the same as the humans who had entered the bottleneck. They had been shaped by over 100,000 years of relentless pressure. They were tougher, more adaptable, more cooperative. They carried the scars of lost genetic diversity, but also the sharpened skills of survival. When the environment finally allowed growth, they were ready. This expansion marked the beginning of a new phase in human evolution. The descendants of those 1,280 survivors spread across Africa and beyond, and as they did, they began to diverge. For the first time, humanity did not move forward as a single lineage, but as three. One group remained in Africa. They continued to adapt to a continent that was still unpredictable, with wet periods and droughts alternating in long cycles. These populations needed to stay flexible, innovative, capable of adjusting quickly to new conditions. Over hundreds of thousands of years, they would give rise to Homo sapiens, our own species, defined by a remarkable ability to adapt and innovate.
A second group moved north and west into Europe and Western Asia. There they encountered a different world, colder, harsher, with long winters and short summers. Life demanded physical resilience and efficient use of resources. Over time, this group evolved into the Neanderthals, stocky, strong, perfectly adapted to the rigors of Ice Age Europe. Their bodies became robust, their noses broad to warm cold air. Their culture centered around hunting large mammals in coordinated groups. The third group journeyed east, spreading into Asia and eventually reaching lands as far as Indonesia and New Guinea. These populations developed along their own path, one less visible in the fossil record, but preserved in the genetics of modern people. They became the Denisovans, a mysterious branch of humanity whose DNA still survives today in populations across Asia and the Pacific. It is striking how quickly this split seems to have happened. Normally, species diverge slowly, separated by barriers of geography and time, accumulating small changes over hundreds of thousands of years. But the bottleneck had compressed evolution into something different. The survivors were like a river forced through a narrow canyon for 100,000 years. When they finally emerged, they spilled out in every direction at once, carving new channels, creating new possibilities. The fossil and genetic evidence align neatly here. Around the same time that populations expanded and diversified, we see the beginnings of new tool traditions. Fire, once sporadic, became more systematically controlled. Stone tools became more complex, more specialized. These changes suggest that the survivors were not simply returning to their old ways, but inventing new ones, shaped by the adaptations forged in crisis. And then came the most extraordinary consequence of all. As these populations spread and evolved into separate species, they carried with them the same genetic signature of survival. The fused chromosome, the narrowed diversity, the adaptations for cooperation and intelligence, all of it remained. Every one of the new human lineages bore the imprint of the bottleneck. In Africa, this legacy manifested as flexibility. Homo sapiens would eventually become the masters of adaptation, capable of surviving in deserts, rainforests, tundra, and coasts. In Europe, the Neanderthals embodied resilience, their robust bodies a testament to generations of endurance. In Asia, the Denisovans displayed ingenuity, leaving behind hints of high-altitude adaptations and perhaps even early seafaring skills.
But all three species were cousins, descended from the same fragile remnant. And all three carried within them the potential for greatness. The archaeological record shows that after the bottleneck ended, human populations did not just grow, they flourished. Technology advanced, social networks expanded, and cultures began to form distinct identities. The spark that had barely survived through the dark ages of drought now flared into something powerful. It is tempting to see this as a triumphal turning point, the moment humanity stepped away from extinction and toward dominance. But even here, nothing was guaranteed. Each branch faced its own challenges, its own risks of disappearance. The Neanderthals would thrive for hundreds of thousands of years before vanishing. The Denisovans would leave behind more DNA than bones, and even Homo sapiens would teeter on the edge again during later climate crises. Yet the pattern had been set. The bottleneck had proven that survival was possible even under impossible conditions. The traits it had selected, intelligence, cooperation, and adaptability, would remain the keys to human success. The silence of fossils during the bottleneck gives way, after 813,000 years ago, to an abundance of signs that humans were once again multiplying, spreading, and transforming. The void is followed by an explosion. Where there had been absence, there was now presence. Where there had been fragility, there was now resilience. The new beginning was not the end of struggle, but it was the start of something larger than survival. It was the dawn of humanity as we know it, diverse, adaptable, and unshakably persistent.
Chapter 7. When the Cousins Met. For hundreds of thousands of years after the bottleneck, three branches of humanity lived and evolved in parallel. In Africa, the ancestors of Homo sapiens grew more adaptable, experimenting with tools and cultures that would one day define our species. In Europe, the Neanderthals became masters of endurance, thriving in the bitter cold of ice ages. And in Asia, the Denisovans spread wide, mysterious, yet successful, leaving traces of their presence from Siberia to the islands of Southeast Asia. For a long time, these worlds were separate. Each population lived in its own domain, rarely aware of the others. But eventually, as climates shifted and populations spread, their paths began to cross. When they did, the results shaped the future of humanity in ways both intimate and profound. The first encounters likely took place in the Middle East. This region, sitting at the crossroads of Africa, Europe, and Asia, became the meeting ground for cousins who had been apart for nearly 500,000 years. Imagine being part of one of those first small groups of Homo sapiens leaving Africa. You know only your own people. Then, across a valley, you see figures that look human, but not quite. Their bodies are shorter, broader, built with thick bones and powerful muscles. Their faces carry heavy brows, their noses large and wide. These were Neanderthals. What happened in that moment? Fear? Curiosity? Hostility? We cannot know the exact emotions of those meetings, but we know the outcome. They did not only fight, they also connected. Genetic evidence makes this clear. Every person alive today outside Africa carries about 2% Neanderthal DNA. That means that when Homo sapiens and Neanderthals met, they didn't just exchange glances, they formed relationships, raised children together, and merged lineages. The same is true with Denisovans. Modern populations in Asia and Oceania still carry between 2 and 6% Denisovan DNA. Our family tree is not a neat sequence of branches. It is a web of crossings, a story of encounters as much as separations.
But interbreeding was only part of the story. These meetings also brought competition. Neanderthals were extraordinary hunters, perfectly suited to Ice Age Europe. They had survived for hundreds of thousands of years in one of the most unforgiving climates on Earth. But when Homo sapiens arrived with new tools and new strategies, balance shifted. Over tens of thousands of years, territories changed hands, sometimes peacefully, sometimes violently. Archaeological evidence suggests waves of expansion and retreat. In one era, Homo sapiens pushed northward into Europe, establishing settlements.
Then, as climate cooled again, Neanderthals moved south, reclaiming lands. For millennia, this back and forth played out, each side adapting, each side testing the other. With Denisovans, the picture is hazier. Their fossils are vanishingly rare, just a handful of bones and teeth discovered in Siberia and a few genetic traces extracted from cave sediments. Yet the DNA tells us they spread across an enormous range, from the cold highlands of Tibet to the tropical forests of Southeast Asia. They too encountered Homo sapiens. The genetic echoes of those meetings remain in the people of East Asia, Papua New Guinea, and parts of the Pacific. Some of the genes humans carry today that help us adapt to high altitudes, for example, came from Denisovan ancestors. These exchanges show us that ancient humans were not separate in the way we often imagine. They were more like rivers branching and rejoining, sometimes flowing apart, sometimes mingling. And each time they met, they left pieces of themselves in one another. Still, cooperation and intimacy had limits. The world was not endless. Resources were finite. As Homo sapiens expanded, competition grew fiercer. We carried with us technologies that gave us an edge, more sophisticated tools, refined use of fire, and eventually innovations like clothing, nets, and spear throwers. With these advantages, smaller groups of sapiens could achieve what larger Neanderthal bands required. Slowly, advantage accumulated.
The story was not one of immediate replacement. Neanderthals thrived alongside sapiens for tens of thousands of years. Denisovans survived in parts of Asia even longer. But over time, one lineage proved more flexible than the others. Sapiens were generalists, capable of living in deserts, coasts, forests, and tundra. Neanderthals and Denisovans, while brilliant in their own niches, were more specialized. As climates shifted, our adaptability proved decisive. By around 40,000 years ago, Neanderthal populations were shrinking. The last of them held on in refuges like southern Spain and Gibraltar. Denisovans, too, dwindled, leaving behind only genetic whispers in modern humans. Eventually, only one branch remained, Homo sapiens. But to imagine this as a story of simple conquest would miss the truth. Our DNA shows that when we met our cousins, we did not just fight them, we absorbed them. Their genes live on in us. In a very real sense, Neanderthals and Denisovans are not gone. They walk in our blood, in the small fragments of their genomes that still shape our lives. The first meetings between cousins, then, were not merely encounters across valleys. They were turning points in evolution. They gave us new genes, new adaptations, and perhaps even new ideas. They reminded us that humanity was never one straight line, but a network of families, diverging and reconnecting, until finally one remained. When Homo sapiens stood at the edge of the last ice age, preparing to spread across the entire globe, we did so carrying the legacy of every cousin we had ever met. The Neanderthal's strength, the Denisovans' adaptations, and the deep resilience forged in the bottleneck, all of it lived within us. The cousins had met. Their time as separate peoples was ending, and a new chapter in the human story was about to begin.
Chapter 8: The Gifts and Scars of Survival. The bottleneck that nearly erased humanity left behind more than a fragile continuity of life. It carved deep marks into who we are, scars that weakened us in some ways, and gifts that strengthened us in others. To understand modern humans, we must understand both. The most obvious scar is our genetic vulnerability. With so few ancestors, variation was stripped away. In biological terms, variation is a shield. It means that when a disease appears, some individuals are resistant even if others fall. But when diversity collapses, that shield thins. Modern humans, despite our vast numbers, remain unusually homogeneous. Compared to other primates, we are like siblings rather than distant cousins. This makes us more fragile in the face of pathogens. A single virus can spread quickly because so many of us are biologically similar. History bears this out. Smallpox, influenza, and more recently new pandemics have swept across continents with terrifying speed. In other species, outbreaks often slow as they encounter resistant individuals. For us, they can burn through entire populations unchecked. That vulnerability is the echo of 117,000 years lived on the edge. Other scars are subtler. Some genetic disorders likely persist because of the bottleneck. Mutations that might have disappeared in a larger population became fixed in ours. Conditions that cause illness today may be the lingering consequence of traits that once offered advantages, or at least were carried by the handful of survivors who passed their DNA to us all. Even now, we live with this genetic inheritance, for better and worse. Yet the bottleneck also gave us extraordinary strengths. It forced traits into prominence that might otherwise have taken much longer to spread, or perhaps never would have. Chief among these was cooperation. In a world where survival hinged on small groups, selfishness was lethal. Hoarding food, refusing to share water, or acting without regard for others could doom an entire band. Natural selection favored not only the strong and clever, but the generous, the empathetic, the cooperative. Over thousands of years, these social traits became ingrained. They did not erase conflict. Humans still argue, still fight, but they made deep collaboration possible.
This cooperation extended beyond immediate survival. It fostered teaching. When knowledge meant life or death, passing it down became sacred. Fire-making, foraging, tracking animals, remembering hidden springs. These were not just skills, but lifelines. Children had to learn quickly, elders had to teach clearly. A culture of instruction, of preserving and transmitting knowledge, became a cornerstone of humanity. Out of this pressure, language flourished. Language itself may be our greatest gift from the bottleneck. Words allowed precision. They carried memory across generations. They enabled planning, coordination, and imagination. They allowed humans to do what no other species could, to live not just in the present, but in a shared vision of the future. It is no coincidence that the bottleneck coincides with the first signs of complex communication. In those desperate centuries, language was not an ornament, it was survival. Our brains, too, bear the mark of those times. Larger, more complex, capable of holding not just knowledge, but empathy and imagination. These changes did not arise in spite of hardship. They arose because of it. In a stable world, evolution favors stability. In a world collapsing around you, evolution favors flexibility, creativity, problem solving. Intelligence was our species' bet against extinction, and it paid off. There is another gift as well, one less visible, but equally powerful:
resilience. Generations of scarcity and danger taught our ancestors to endure, to adapt, to persist when all seemed hopeless. That resilience remains in us. It is what allows communities to rebuild after disaster, what allows individuals to survive trauma and continue. Deep within, we are descendants of those who would not give up. But perhaps the greatest paradox is this: the very fragility that almost destroyed us is also what binds us together. Because our diversity is so low, because we are all descended from the same 1,000 ancestors, humanity is, in a very real sense, one family. Geneticists have shown that two humans chosen at random are far more alike than two chimpanzees from neighboring forests. Beneath the surface differences of language, culture, and appearance, we are astonishingly similar. This is both a weakness and a strength. A weakness because pathogens can sweep through us. A strength because it reminds us that division is an illusion. The rivalries and conflicts that consume so much of our attention are, in the long view, quarrels between siblings. Every face you see, no matter how different, carries the same ancient story, the story of survival against impossible odds.
The bottleneck was not a clean slate. It was a scar, but one that healed into something new. The pain of lost diversity gave us vulnerabilities we still struggle with, but it also pressed us into cooperation, into teaching, into language, into intelligence. It made us who we are. When you look in the mirror, you see both sides of that inheritance. You see the fragility of a species that nearly vanished, and you see the strength of a species that refused to. Every weakness and every gift, every flaw and every brilliance comes from that crucible of survival nearly 1,000,000 years ago. We often imagine ourselves as masters of the earth, as though our place here was inevitable. The truth is humbler and far more powerful. We are not inevitable. We are improbable. And that improbability is our greatest story.
Chapter 9. Echoes in the Present. It would be tempting to think that the bottleneck of 900,000 years ago is nothing more than a distant memory, buried in DNA and stone. But its lessons are not confined to the past. They echo into our present lives, shaping how we respond to crises, how we connect with one another, and how we confront the challenges of a changing world. One of the clearest echoes is our vulnerability to disease. When a new pathogen appears, it sweeps through humanity with startling speed. We saw this in the plagues of history, and we see it in modern pandemics. Our ancestors' loss of genetic diversity means that when a virus finds a weakness, it often finds it in all of us. The struggles of the past live on in the fragility of our immune defenses. In a sense, every pandemic is a reminder of the thinness of our genetic shield, a scar that has not yet faded. Yet alongside fragility is resilience. Just as our ancestors learned to survive endless droughts, we too adapt to disasters. Earthquakes level cities, floods wash away homes, wars tear apart nations, and still humans rebuild. This is not just optimism, it is heritage. For a species that lived on the brink for over 100,000 years, rebuilding is second nature. We carry resilience in our blood. The bottleneck also left us with a profound capacity for cooperation. In times of crisis, humans come together. Neighbors share food during shortages. Strangers donate after earthquakes.
Communities unite against common threats. This instinct has limits. Self-interest always competes with altruism. But when the stakes are high, we remember what kept our ancestors alive. Survival is collective. In our globalized age, this lesson is more urgent than ever. Climate change, pandemics, resource scarcity, these are not challenges any one nation or people can solve alone. They mirror the trials of the bottleneck on a planetary scale. Just as small groups once had to cooperate to endure, humanity as a whole must learn to act as one if we are to navigate the crises of our century. Another legacy is adaptability. The humans who emerged from the bottleneck were generalists. They learned to survive not by specializing in one food, one climate, one tool, but by adapting to many. That same flexibility is why humans thrive in deserts, jungles, tundras, and megacities. We are, at our core, a species of improvisers. Today, that adaptability shows in our technology, our cultures, our ability to rethink the world in the face of new problems. From renewable energy to vaccines to global communication, our solutions are modern expressions of an ancient survival instinct.
Even our drive to share stories and knowledge traces back to those times. Around ancient fires, humans told stories not to entertain, but to remember, to encode vital lessons about water, food, and danger. Today, we still tell stories, though now they take the form of books, films, data, and digital networks. The scale is greater, but the impulse is the same: to pass on what we know so others may survive. The very act of you listening to this story is part of that ancient chain. There is also a deeper echo, our sense of unity. Because the bottleneck reduced our diversity so dramatically, all humans alive today are astonishingly alike. Beneath the surface of culture and appearance, we are one family. Modern science proves what our DNA has carried all along. We are closer to each other than we often imagine. In a world fractured by division, this truth is quietly radical. The rivalries that dominate headlines are, in the long view, quarrels between siblings. This unity is not abstract. It has practical meaning. It means that solutions developed in one corner of the world can apply in another. It means that a vaccine created in one lab can save lives across continents. It means that when disaster strikes in one place, aid from another is not just generosity, it is kinship. We share not only a planet, but a lineage. The bottleneck also offers a warning. Our ancestors came close to extinction because of climate change, natural shifts and cycles they could not control. Today, we face climate change of our own making. The lessons of the past are clear. When environments collapse, populations collapse with them. Our ancestors had no choice but to endure. We do. We can choose to act, to preserve the balance of the earth on which our survival depends. If we ignore the warning written in our DNA, we risk repeating history on a scale far greater than before. And yet, in this warning is also hope. If humanity could survive 117,000 years on the edge of extinction, scattered in fragile bands across a hostile continent, then surely we can survive the challenges we face now with all the knowledge, technology, and cooperation at our disposal. The resilience that carried us through the darkest age in our history still lives in us.
The bottleneck is not just a chapter in prehistory. It is a mirror. It shows us who we are, vulnerable yet resilient, fragile yet adaptable, selfish yet cooperative, fractured yet one. Every time we face disaster and rebuild, every time we share knowledge across cultures, every time we remember our shared humanity, we are living echoes of that ancient trial. And so, when we look at the crises of our age, climate change, pandemics, inequality, we should remember, we have faced worse. We have been fewer. We have been closer to the brink. And we endured. The question is not whether we can survive. The question is whether we can learn to do so wisely, together, carrying forward the gifts of our past while heeding its warnings. For the story of the bottleneck is not only about how we once lived, it is about how we must live still.
Chapter 10. The Lesson of the 1280. 900,000 years ago, the human story almost ended before it began. The earth grew colder, drier, harsher. Ecosystems collapsed, animals vanished, and the fragile thread of humanity thinned until only 1,280 breeding individuals remained. They could not have known that they carried the future of an entire species. They could not have known that in enduring they were shaping the destiny of billions yet unborn. Today, when we look around at the world, its cities, its machines, its endless voices and stories, it is almost impossible to imagine that it all traces back to so few. Yet the truth is undeniable. Every person alive is descended from those scattered survivors. Kings and peasants, scientists and artists, every language spoken, every culture created, every dream ever dreamed, they all rest on the endurance of a handful of families who refused to vanish. The lesson of the 1280 is written into us. It tells us that survival is not a matter of strength alone. It is not the largest population that endures, nor the most specialized, nor even the most powerful. It is the one that can adapt, cooperate, and persist when the odds are hopeless. Humanity did not triumph because we were invincible. We survived because we were fragile and yet willing to hold on. This paradox defines us still. We are vulnerable to disease, to conflict, to the forces of nature, and yet we are also uniquely capable of resilience. Our capacity for cooperation, for storytelling, for teaching, for imagining futures that do not yet exist, these are the gifts that saw us through the bottleneck, and they remain the tools that will decide our future. The echoes of that ancient crisis remind us of something humbling. Survival is never guaranteed. We are not the inevitable masters of the earth. We are survivors of chance, of struggle, of extraordinary persistence. The planet does not belong to us because of destiny. It tolerates us because of adaptability. We are here not because we were meant to be, but because our ancestors endured long enough for us to exist. And if we remember that, perhaps we will live differently. Perhaps we will take seriously the threats we face today, the warming climate, the fragile ecosystems, the weapons we build, the divisions we nurture. These are dangers no less real than the droughts and cold that nearly ended us before. The bottleneck warns us that collapse is possible, but it also shows us that survival is possible, even when the odds are almost impossible.
In a sense, we are always living in the shadow of those thousand souls.
Their blood runs in us, their choices echo in us, their resilience whispers in every heartbeat. They are the reason you can listen to this story, the reason I can tell it. Their endurance is the foundation of everything we call human. And so the final lesson is this: we are one family. Every line of ancestry, every strand of DNA traces back to the same tiny group. Beneath the colors of our skin, the languages of our tongues, the borders of our nations, we are kin. Our differences are surface, our sameness is profound. We are siblings quarreling in the house of earth, forgetting that we are lucky to exist at all. 900,000 years ago, the world almost lost us. Today, we stand in our billions, facing choices that will decide whether our story continues or ends. The past tells us it can go either way. It tells us extinction is always a possibility, but so is endurance. The choice rests with us, as it once rested with them. The bottleneck is not just a chapter in prehistory. It is a mirror held up to humanity. It asks us, will you remember what it means to survive? Will you cooperate, adapt, and persist? Or will you forget and fall as so many species before you have? The survivors of 1280 left us no monuments, no cities, no words carved in stone. Their legacy is simpler, but greater. It is us, all of us. And that is the gift we must not waste.